Good morning, everyone. I hope you're enjoying these awesome talks as much as I am on this really awesome conference. This is Geospatial analysis, so let's get started. So my one small claim to fame in the Elm community is this library called Gampleman/Elm Visualization, which allows you to make custom data graphics, charts, diagrams, or even custom controls for your applications. And when I started building this a few years ago, I needed to scope what I'm going to put into that library and what I'm going to leave out, and what might be some nice to haves in between. And the first thing I kind of decided to leave out was anything to do with geography or maps, because I didn't need it at the time. And if I don't need it, so probably nobody else does. And second of all, it was really complicated. I didn't know anything about it. So I was like, yeah, I'll leave that for someone else. But life goes on in kind of funny ways, because not very long after I made this decision, I switched employers. And I started working for my current employer, Astrosat. And we work with a lot of satellite imagery. And it turns out satellite imagery, as you can see from the different screenshots of our different apps, kind of lends itself to be shown on top of a map. And so, I was thrown into this cartography or mapping stuff nose first, and I started to learn all of this stuff the hard way. So one of the first projects I was assigned to was completely Greenfield, and I had the bright idea, and I said, let's build it in Elm for all the benefits all of you already know. And it went pretty well. We managed to build our MVP product, shipped it, and celebrated some success. All was well. But on the engineering side, we sort of needed to make this map, and at the time there was no libraries out there, so we did what was recommended at the time and used ports, and it worked. But the JavaScript side of the code base was really organized to support these ports, but also to manage this very complex piece of UI that is a web mapping application. And the logic was organized to support those ports, not to support the internal logic. And so it ended up very tangled. And also the business logic of the application was split between the Elm part of it and the JavaScript part, with no appreciable reason than sort of the implementation necessities of that split. And so our JavaScript application really started resembling like those jQuery scripts of old, where it's just this one big file of madness. Anyway, our story goes on. This project was put on hold for a year for completely other reasons. And I was put on different other projects where I was building lots of mapping applications in React. Got a lot of experience in the meantime. But I knew this Elm project was going to come back, and I wanted to have a good solution to some of these challenges. And so I spent that year working on 2 open source packages that I would like to talk to you about today. The first of those is Gampleman/Elm Mapbox, which is kind of a strange library because it's a hybrid library. It has an Elm part and a JavaScript part. And when you set it up, these 2 parts communicate together, and they provide you with a very fast, performant, high-quality client-side mapping platform, which allows you to visualize your own data on these maps. And because of this Elm part to it, you can do all of that from your Elm code base without needing to touch any of that JavaScript. And you can do that in a really type-safe and convenient manner. And the other package that I have been working on is Gampleman/Elm Geospatial, which is a more abstract package that deals more with geospatial analysis and these sort of things. And there are 2 separate packages because not all applications need both of these things. Some applications just want to show some map data that comes from some backend and don't really care to do much with it. And other applications might want to deal with geographical data, but might not want to present it on a map. But obviously, they also go really well together. Now, this might sound kind of abstract to you, so I decided to spend some time and go through an extended real-world example of what some of the things I've done in my job where these sort of things have come in useful. And in this case, we were trying to help people in Malaysia deal with flooding. In order to do that, we needed to visualize hydrological data around the country. And hydrological data in Malaysia comes from these stations that are of 3 different types. There are rainfall stations that are kind of like a bucket, and they measure how much water is falling from the sky. You have water level stations that measure how much water there is in a river, and you have combined stations that are both of those things. And all of these are coming to us from a third party we don't have any control over. It's you take the data or you leave it, and we want to do something useful with them. So we're going to set up our app here. And this is all set up already, and most of the logic here is happening in the view. So I've alighted most of the code, but this is the interesting part. And here we're going to set up our map with mapbox.element.map. And this is not mapping over a data structure. Naming is hard. This is actually giving you a map, as in like road map. And it takes a list of attributes, in this case, none, and a style that we're going to produce with this build style function. It's going to take our model and turn it into a style. Now, a Mapbox style in Mapbox is a data structure that has different properties, but the most important one of these are sources and layers. Sources describe how and from where you're going to get the data that powers your map. Maps load data lazily, so if I'm wanting to look at a map of, say, Paris, I don't want to be fetching data to describe the geometry of, say, New York. But if you pan the map to New York, you need to load that data. So sources describe where to get that data from, what format, and so on. And that data is then fed to layers, which say, I want to show, for example, roads as lines, and I might want to show cities as icons with labels. So you can think of this a little bit like the separation between HTML and CSS. It's kind of a weird analogy, but... And once we take all these layers, we kind of composite them, and that ends up being our map. So in our build style function, we're going to take a pre-made style. This is called Mapbox Lite. It does things like show cities and roads and seas, and we're going to add some of our custom sources and layers to visualize this data. So we're going to end up taking a source from a remote URL. This is what our partners have provided us for this data set. Then we're going to call it flooding. And then we're going to try to visualize this data as a bunch of circles. So we're going to say this is going to be a circle layer called points, taking data from this flooding source. And then we're going to do what Mapbox calls data-driven styling. What that means is for every particular station in that data set, we're going to try to find some of its properties and change the visual appearance of our points based on those properties. So in this case, we're going to say, give me the station type. And then we're calling matches string, which is kind of like an Elm case statement. So it's going to say if it's a water level, I want it to be 1. If it's a rainfall, it's going to be 3. If it's going to be combined, it's going to be 5. If it's something else, defaults to 1. And then we're going to pipe that and say that's going to be the radius of that circle. For the color of the circle, we're going to do the exact same thing here, but where some of these are rainfall, some of these are water level, so we're just going to get something quickly done, we're just going to take the first one of those that isn't null. So that's what this coalesce function here does. And we're just going to turn those into some sort of color and set the layer color. And this is the result. So congratulations, we've built our first map. Amazing. But it has some difficulties, this map. First of all, the water level and the rainfall are kind of 2 different things. If you're trying to predict a flood or deal with it, you need to interpret those 2 things in different ways. And here we've all drawn them as circles. So that's sort of a weakness. And the other weakness is more on the code side, is that we're taking this really messy data source in, and we're just trying to sort of swallowing a whole bunch of things and dealing with it at the view layer. And this is not great. So I'd like to improve both of these things. And to improve these, we're going to use an awesome feature that I really like, and a lot of you probably don't, but it's called JSON Decoders. And they're really great for dealing with messy data. And if you're going to deal with geospatial stuff, messy data is more the norm than you would like. So in this case, we want to model some of this messiness explicitly. So we're going to say, hey, our station can be either water level or rainfall or combined, or it can be garbage, because some of that data doesn't make any sense. So we're going to model it explicitly because we want our decoding to succeed at least partially. And we're going to get rid of that garbage data later. Then we can build a decoder that, not going to show all of it, but basically its property is it will try its hardest to decode this correctly, but if it can't, it'll just produce garbage. And then we build some functions that allow us to extract either the rainfall or the water level. So, and we will use these later on with a filter map to just get rid of the garbage eventually. And then we have to build our models for the rainfall stations and the water level stations. And these are almost exactly the same code, so I'll just show you the rainfall stations. And these, funnily enough, can be turned off or on because they're probably solar paneled. So if it's cloudy, they're going to turn off. Or if somebody hits them with a baseball bat, it's going to turn off. Or for various other reasons. And then if they're on, they can tell us something about the conditions there. And if you squint, this really looks like a maybe. We're just going to add a function to turn it into a maybe. And then finally, we need a decoder. So we build that. And then we want to turn this into a Mapbox source that we've seen previously. So we're going to say, hey, I want to turn this into a source. In order to do that, we need to have a way to encode that data back into JSON, because that's what Mapbox deals with. So we're going to build a quick encoder just for the status. But you saw there that we're using something called feature collection. Now, feature collection is one of the main module in Geospatial. And it's built around this type called a feature collection, which is what you would usually store your geographical data in. And the feature collection is literally just a list of features. It's a type alias. And a feature represents a thing in the world. And as such, it has some geometry that tells you where in the world it is, and some arbitrary data that in this case we call properties. That's the type variable there, which is something your application can decide whatever it wants to put there. So that's some arbitrary data that you store about that thing. There's also another type variable here called coordinates. And the reason for that is that the Earth is a very strange shape. It's not a sphere. It's not flat. Something weirder than that. And there exist multiple ways of describing coordinates on the Earth. And different use cases, different of these systems are better. Most of the functions in Geospatial, except this coordinate system called WGS84, you can think of that as GPS coordinates. So that's longitude and latitude in degrees. But you can use your own, and you've got type safety, so you can't mix these up accidentally. The module also provides input and output, so you can decode and encode from common formats, at this point mostly GeoJSON, and there's various more advanced encoders and decoders that help you do that in stranger circumstances where the data is even worse than what I've been showing you here. And we also provide ways you can manipulate your own custom stuff in the properties without ignoring all the geometry. So you can map over your own custom data, but the geometry stays the same. We also provide you with stuff to manipulate the geometry and keep the data the same. So it gives you a lot of flexibility here in storing your stuff. So we'll put all of this to use now. And we're going to say, this time we're going to fetch the data manually with HTTP. And when it loads, we want to process it in some sort of way, and then store the result in our model. Now for processing, we're going to use filter map to get rid of first the garbage, and then get rid of all of the stations that are off, because stations that are off also don't provide any value for our users in this case. And this way, we're going to end up with our two separate things. Then we're going to have to modify our build style function to take advantage of these new sources that we've built. And now we've dealt with the messiness of our data. But we also said we want to separate our data into two different visual representations. In order to do that, we're going to use a wonderful thing called a Voronoi diagram. So I'll take a little aside to explain that. So imagine you have a two-dimensional plane, and on this plane you have a few points that we're going to call sites here. Now for all the other points on the plane, there's one of three conditions can take place. Either that point is closest to one of these sites. In this case, we're just going to assign it to it. Otherwise, it can also be closest to exactly two of these. And these points are going to form the boundaries between these. And finally, it can be closest to three or more of these points, in which case these are going to be the intersections of these boundaries. So we can draw those, and then these kind of turn into polygons. And these polygons have the wonderful property that every point in these polygons is closest to the site that generated them. So we've divided the plane in such a way that we know where every point is closest to. And this is actually exactly what we need here. So we're going to use the built-in Voronoi function and use it to transform these points into polygons that will cover our map. And because these can be infinite, we need to add a bounding box that will clip them. In this case, we're just going to draw a bounding box around Malaysia. And this is what it looks like. And, well, it looks different. And you might say, well, Jakub, this kind of looks like abstract art. I'd like it to be more of a map. Fair enough. So let's do that. So we're going to do a thing called Polygon Intersection. So the idea, it's the same like sets, but for polygons. So we're going to take two polygons and keep the part where they both overlap each other. And so in this case, we're going to take the shape of Malaysia and intersect it with each of these polygons that we've created to sort of cut out a shape that looks more pleasing. And I'm going to skip the code this time for brevity. But this is the result. So we've now cut out all the weird overlaps, and we've created a map that covers the country in this relatively pleasing way. Now, you can be judges whether this is an effective way or not of visualizing this particular data set. Spoiler, we didn't end up using this in the end in our product. But the point is, you can use these tools to combine them in various different ways to create something unique that solves your problem. So in summary, we've used JSON decoders to deal with very messy geospatial data. We've made a Voronoi diagram to transform those points that we had into polygons. We've ran intersections to clip those polygons. And we've used Mapbox data-driven styling to visualize the result as a map. And I encourage you to try that yourselves. And you can do that, sort of. Gampelman Mapbox is at version 4.1. It's used in production by Astroset, by New Zealand Herald, a few other places. So it's ready to use now. I was hoping to be cool and release Geospatial here on stage. Life doesn't always work out that way, so it will be available later this year. So please try to build a map. It's a lot of fun. Any questions?
Does anyone have questions?
Right over there.
Thanks for the talk. How do you choose the center of the polygons in your Voronoi diagrams?
So in this example, the centers are the locations of the rainfall stations, right? So we want to know, in this case, we want to get an estimate of what the rain looks like across the whole country. So we know what it is at one particular point, and we want to use this as a sort of a unbiased way to estimate it for the rest of the country. So the centers here are the positions of the rainfall stations. Does that answer your question? Yeah.
Any other questions? Okay.
All right, thank you very much.
Thank you very much.
Yeah.
It was very nice.